Differential Calculus, Chapter 9, Differential Calculus, Limits and Continuity. Exercise 9.1, question 14. And question number 14 is, limit x tends to 0 secant x. Find the value of the limit using the graph. The graph is given below. By using this graph, find the value of the limit of the given function secant x. Here our limit value is x tends to 0. The position of a 0 on x-axis is this point. The position of a 0 on x-axis is at this point. And all the points, so leftwards of this 0, minus pi by 2, minus pi, all are leftwards of 0, and plus pi by 2, plus pi, all are rightwards of 0. This arrow mark represents leftwards approaches. This arrow mark represents rightward approaches. Now draw a vertical line through 0. Draw a vertical line through 0. That vertical line meets a graph, meets a curve at 1. Meets a curve at y is equal to 1. So y is equal to 1. This point is named as, or this point is noted by 0, 1. This point is noted by 0, 1. And this meaning is when x is equal to 0, the value of the curve on y-axis is 1. Therefore, limit of the given question is 1. So when x is equal to 0, the value of the curve on y-axis is 1. Therefore the limit x tends to 0 secant x is equal to 1. Therefore, limit value of question number 14 is 1. Therefore, question number 14 is over. Question number 14 is over. Now, question number 15. So, question number 15. The question number 15 is, limit x tends to pi by 2 tan x. Find the value of the limit of the function f of x is equal to tan x by using the graph. By using this graph, find the value of the limit of the given function tan x. Here our limit is x tends to pi by 2. So the pi by 2 on x-axis is here. Pi by 2 on x-axis is here. So all the points 0, minus pi by 2, these are leftwards of plus pi by 2. And pi, 3 pi by 2, all these are rightwards of plus pi by 2. This arrow mark represents leftwards approaches and this arrow mark represents rightward approaches. So now through the point pi by 2, we can draw a vertical line. Clearly, this graph shows that the vertical line doesn't meet the curve anywhere. The curve is like this, and here is the graph is moving like this. The graph is going on. The vertical line is also going on. This graph shows that this vertical line doesn't meet the curve anywhere. Therefore, the limit of the given question doesn't exist. Solution: when x is equal to pi by 2, when x is equal to pi by 2, the vertical line through pi by 2, does not meet the curve anywhere. Therefore, at x is equal to pi by 2, the value of the curve on y-axis doesn't exist. Therefore, the limit of the given function, limit extends to pi by 2, tan x doesn't exist. Therefore, the limit value of the question number 15 doesn't exist. Therefore, question number 15 also over. Thank you.